Assalamualaikum and hi! The title chosen is Titration in Detergent Industry. So what is titration and how can it be used in detergent industry? First thing first, titration or volumetric analysis or titrimetric analysis can be defined as a procedure used in analytical chemistry to determine the amount or concentration of an analyte. In this case, the concentration of analyte that we want to determine is the ingredients that were found in the making of detergent. The origins of volumetric analysis are in late 18th century French chemistry, where the French word titrate also from this origin means rank. Next is the theory behind titration. The type of volumetric analysis used in detergent industry is the acid-base titration. It is used to determine the amount of acidic or alkaline substances present in the detergent sample. This theory can be applied by monitoring the change in pH during titration when acid or base is added. Titration method also helps to adjust the pH and identifying the concentration of active cleaning agents to ensure good performance.
Indicated on this slide, the chemical reactions in detergent titration can vary depending on the type of detergent or surfactant being analyzed as well as the titration method used. Let's look at the chemical process here, which is a common method for producing alkyl benzene sulfonate, a key component in many detergents. In step 1, alkyl benzene reacts with sulfuric acid to form alkyl benzene sulfonate acid. In step 2, the alkyl benzene sulfonate acid is neutralized with sodium hydroxide, also known as lye or caustic soda, to produce the alkyl benzene sulfonate salt and water. We can see from this slide, the equivalence point is crucial in titrations involving detergents where there are significant changes in pH. This point is observed using pH indicators which help visualize the pH changes during the titration of detergent solutions. In the graph, we observe a typical titration curve. The equivalence point is marked when the steepest part of the curve occurs, indicating a sudden change in pH. This is where the amount of titrant added exactly neutralizes the analyte solution. We use various pH indicators to detect this point. Some common examples include phenolphthalein, bromothymol blue, and methyl orange. Each of these indicators changes color at different pH levels, allowing us to accurately determine the equivalence point during the titration. In this slide, we will walk through the stoichiometric calculation. So the first step is balancing equation. The equation shows that 2 moles of lithium hydroxide react with 1 mole of carbon dioxide to produce 1 mole of lithium carbonate and 1 mole of water. Next step is to convert mass to moles. We will start with 1 kilogram of lithium hydroxide. So when converting, we will get 41.8 mole of lithium hydroxide. The next one is mole ratio. Using the balance equation, we determine the mole ratio between lithium hydroxide and carbon dioxide. The equation indicates that 2 moles of lithium hydroxide react with 1 mole of carbon dioxide. Next, moles of carbon dioxide needed. Based on the moles of lithium hydroxide, we calculate the moles of carbon dioxide required, and we will get 20.9 mole of carbon dioxide. The last step is to convert from moles to mass. Finally, we will convert the moles of carbon dioxide to mass using its molar mass, and the final answer will be 920 gram of carbon dioxide. This stoichiometric calculation allows us to determine that 1 kilogram of lithium hydroxide will require 920 gram of carbon dioxide to fully react, producing lithium carbonate and
In this slide, I'm going to talk about the process of titration. The first one is preparation. First, rinse all glassware with distilled water to remove any contaminants. Then fill the burette with titrant solutions. Make sure there are no air bubbles in the burette. Then, you need to record initial volume of the titrant in burette. Second, for the sample preparation, place a measured volume of the analyte into a clean conical flask. Then add a few drops of appropriate indicator. Then we have titration. First, slowly add the titrant from burette to the analyzed solution while continuously swirling the flask. Then observe the color change of the indicator, which signifies the endpoint of titration. Then we have endpoint determination. The endpoint is reached when indicator changes color permanently. Then we have to record the final volume of the titrant in the burette. For the last one is calculation. Calculate the volume of titrant used by subtracting initial and final volume. Use titration formula to determine concentration of analyte.
Next, we will continue to talk about the procedure in titration process. The first one, we need to determine the material and the apparatus needed for this experiment. The first one is surfactant, which is the primary cleaning agent, titrant solution, indicator, burette, pipette, and also conical flask. Next, I will talk about the procedure in titration. The first one, we need to measure any detergent sample that contains the surfactant and transfer it into 250 ml volumetric flask. Then, fill the volumetric flask with the distilled water until it reaches the calibration mark. When the distilled water is already half, we need to use the dropper to fill the distilled water up to the calibration mark to ensure the accurate measurement. Next, we need to mix the solution inside the volumetric flask in about 2 to 3 times. After mixing it well, transfer the detergent sample in 100 ml conical flask and add a few drops of any indicator. It could be the phenolphthalein, bromomethyl blue, or maybe the methyl orange. Add the indicator into the conical flask and prepare to titrate. When we wanted to titrate the solution, we need to use a standardized solution from the burette into the conical flask. Titrate the solution until the color change is shown. Lastly, record the volume of titrant of solution used to change the color of solution in conical flask. Use the simple formula, which is the initial reading minus the final reading of the burette, to determine the volume of titrant used. Here are some uses of detergent. It could be the laundry detergent or any fabric softeners, dishwashing liquid, bleaching products, and rinsing products.